Hello everyone, I'm Shreya and I welcome you back in this machine learning tutorial series. So, till now we saw that is what is grid search with the help of an example, and also saw the meaning of grid search and hyperparameter tuning. And we saw that how we can apply grid search, and we also saw in which like library the grid search function is there, and we also saw the cones of grid search, and that is parameters are limited and the process is time consuming. So now it's time to implement the grid search using Jupyter Notebook and Python. So the dataset that I'm going to work upon is Iris datasets that you must have been familiar with from since day one of the implementation of the algorithms. So the first thing that I have done is that I have imported SVM, as we are like in the PPTs as well, as you can see, we suppose that we are working on SVM for finding the predicting the species of the petals. So now for that we import pandas. After that we import SVM and datasets from the sklearn. So we try to load the iris datasets and import pandas as PD and data frame to work upon, so that we can have the columns as a feature columns which are features, and this data and data flower as the target, that is the flower species, that is Cetrosa versicolor and Virginica. And for that we are applying the values also, and this data set that we are going to work upon is 47 to 150. So the columns has 103 rows and 5 columns, and for that we import a train test split from the sklearn.model selection and cross val score from sklearn model selection, and x train x test, y train y test, and train test split with the test size of 30% and train size of 70%. For that we are implementing SVM, as we are already familiar with SVM, and we saw that how we can apply SVM using SVC. So the parameters that are going in is kernel as RBF, and C30 and gamma as auto, and we are fitting the model using the X train Y train and scoring the model using X text Y test. And for that after getting that after a simple implementation of SVM, we are getting 97% like as on kernel RBF and C30. Only on this parameter we are getting 97% accuracy. And if we try to view using a cross value score, using like that is fold of like we can cross validation, for that we are getting this much score, and changing the value of C and kernels, we are getting these results. So as you can see, we have different results, and depending on the parameters that we are applying. So there is a possibility that there is some parameter frame which can be hold out as a best or giving the efficient result. So and now after that I imported numpy as numpy, and kernels is equal to RBF and linear. As you can see, we are applying kernels as RBF and linear, and C as 1, 10 and 20. So the total number of results that we can expect is RBF on 1, RBF on 10, RBF on 20, and linear on 1 and 10 and 20, and we calculate the average score. Using in this line we are doing with the help of cross validation only. We are generating a loop, and the time complexity will be around at how much the value of C value is there, that is 3, that is order of n will be the complex, or not order of n, that is order of n square, because suppose this is n, kernel's value is n, and C value is also n. In that case we are getting n square like time complexity, and for that we have the results as 0.96, 0.97, 0.98, 0.96, 0.98. So on these scores we are getting the results, that is the accuracy. And for that, as you can see, we are applying on order of n square. So for that, I'm going to use grid search. So for that, I have imported grid search from the sklearn model selection, and I have applied gamma as 20 and c I have already discussed that this is a discrete grid and kernels. So cv is equal to 5 and return train score is equal to false. And cliff fit and iris dot data is iris target, and cliff dot cv underscore results underscore. So these are the from here we can have the result using clf dot cv results. So I'm doing the same thing, but you can see the number of lines we are executing here. The complexity will be less than order of n square, that is it will be order of n only, because we are applying it in single line. As you can see, this is the single line for the clf. And if we see the results are very unclear for us. But you can see we have mean test score here. That is the test score that we are getting, that is accuracy that we are getting. But sklearn provides us a function that is called data frame, which converts it into a data frame. So with that, if we try to view, so here we have this structure in the form of data frame or and matrix form. And we can see we have a split 0 to a split 4. So total 4 split we have, and mean test score depending on that. But we try to there are many columns which are very much not useful. So for that we are using df, which can drop out the different columns that we have. So that is param c and param kernel and mean test score that we have. So now, as you can see, we on the basis of C1 RBF, we are getting 90, 98, and one on linear we are getting the values as this. So if we from here we can see that we are getting the values best here as a c value is 1 and rbf as 1, and 1 as linear, 1 as c, and a kernel as linear. If we try to get the best performance from the clf itself, then we have to call up a function that is clf dot best underscore parameters are underscore, then we get this result. And if we try to get the best result, then this is the result. And if we try to understand the different objects and different attributes related to this object, then we have this much attributes, that is best parameters best score, that is the best parameters better score, that is related to this clf, that how many things that we can use with the help of clf. Then we can see we have best parameters and best score. So I have used best parameters and best score. So that's all in this video. Hope you liked it and enjoyed it. So this was all about the demo of grid search cv. And hope you all understand what I was trying to make it clear in your mind, that it is one of the a very efficient way or easy algorithm to implement this much process, that is getting the different values, that is of order of n squared to order of n. So that's all in this video. Hope you liked it and enjoyed it. Stay blessed. Thank you.